Okay, so this one's been the elephant in the room forever. Most people love it, some people hate it, but let's talk about it. And it's the driver monitoring in OpenPilot. I'll just call it DM for the rest of the talk. Here are the topics I would like to cover today to hopefully demystify Comma's camera-based DM approach. Let's start with the basics. So what's the goal of DM? What are we trying to achieve with it? As we all know, Comma is proud about shipping a very good level 2 system. And as the system is getting better and better, we need to remind people that they always need to pay attention in a level 2 system to your driving surroundings. Therefore, the direct goal of the DM is to keep the driver engaged. And obviously, by using the camera only, driving now becomes more chill because the driver now doesn't need to touch the wheel every now and then when the system is engaged. When we say keeping the driver engaged, it means to make sure the driver is always paying attention to the role that they should be always to be ready to take over. Some examples of not paying attention includes being on your phone, falling asleep, or even simply by just looking at the car nestling for too long. Now that we have the problem in mind, let's fast forward and take a quick peek at what Comma DM has achieved so far by looking at some numbers. Got here. The first one is a comparison plot between having DM and no DM, showing the cumulative. The plot shows the cumulative distributions between of distraction durations between current data and the data we had before we shipped OpenPilot DM. The green line is from recent fleet data, and the orange line is from running the same model on the data we had before DM was shipped. Both lines show data when the OpenPilot is engaged only. If we zoom into that section there, in recent data, 99.7% of the distracted events are less than 5 seconds, while in the old data, this number is 97.4%, which means DM has managed to reduce distractions more than 5 seconds by 90%, which is substantial. Here's another interesting stat. So at runtime, DM is only active when OpenPilot is engaged, but how about when it's not engaged? By assuming DM is always alive, we can rerun the policy and the model offline on all the logs to compare the amount of DM alerts each user will have gotten per minute, both engaged and not engaged, as shown here. So the results show that when OpenPilot is engaged, drivers get 60% less alerts on average when compared to when they are driving themselves. Thus, we can say that when engaged with OpenPilot, people pay 60% more attention, in the sense that DM helps to remind people that they need to be paying attention. It's not the fact that it beeps. It's the fact that you know it would beep at you if you don't pay enough attention. In a way, it's similar to speed limits. Say it's not about it's not about the consequences. It's mostly about the presence. Which brings us to this graph. To sum things up, DM basically achieves two things. One is that it reminds people when they're getting distracted without actually knowing being distracted. The other one, more importantly, is that it keeps people from involving in distracted behaviors in the first place. So how does everything work? We start by looking at what happens in OpenPilot, from sleeps to beeps. So we have the driver-facing camera that takes the picture of the driver, say here with this beautiful comma-free camera. And then the picture is fed into a neural network to estimate some parameters of the driver. We call these parameters driver stage, which includes things like whether there's a face, where's the face, where are the eyes closed, where the face is looking at, stuff like that. Then we have a classical state machine that takes in the driver state, all these parameters of the driver, and process them in loop as new pictures come in. It also takes into account things like the speed of the car, and also how the camera is mounted, or even how complex is the scene, to adjust all the things. Then the system will use all these information to determine whether the driver is being too distracted. And if they do, an alert will be shown. You get the beeps. Of course, the brain of all these is the neural network model we use to extract information from the picture. Now let's zoom in more and look at the model itself. In like a more technical terms, the model is an efficient vision network, which is 8-bit quantized to run on the DSP instead of the GPU, such that the DM model doesn't compete for resource with the driving model, such that they can both have room for growth. Say we want to train big model in the future for both of them, we can do that. And the two main outputs will be the driver's head pose and eye stage, which are the two cornerstones of OpenPilot DM. It may not seem much, but as we shall show here, we shall be showing, these two aspects are actually proven to be quite versatile when it comes to determining driver attention. Here are a few examples of DM model in action when I was driving. We can see that by just looking at only the head and the eye, you can actually catch things from simply looking away or playing with your phone when driving, or the even more subtle, like falling asleep somehow. And of course, the model works both day and night. Well, you might now wonder how the measly 8-bit model can do all these tricks. As George always says, the most important aspect of machine learning is, of course, the data. So the next talking point will be our data. The latest DM model is trained with more than 23,000 hours of driver videos uploaded from over 1,600 unique users from our fleet, which makes up roughly 25% of the total user space. Thanks to them, OpenPilot DM can be as good as today. We would love to see this number grow, and in the coming slides, I'm going to show what we are doing with the data and why more people should upload. Well, some people might be worried that their faces will be looked at when we label the data, and thus have concerns about privacy and stuff like that. And yes, we do have our diligent data labelers, but they are machines. So these beautiful computing clusters that Greg built are also our DM labelers. Here I have 3 pictures for them because we have 3 racks. So how are the ground truth generated? So we have been building this DM data annotation pipeline for almost 2 years now, which can do the following task in a fully automated manner, so that no human would need to look at the data, any of the data. Here are some of the examples of our auto ground truthing stack in action, where you can see faces being detected and the pose being accurately estimated, and also as well as the eyes and whether they're closed. So what's actually doing all these things are what we call the teacher models that we train separately to work specifically on our data set using a technique called transfer learning, which means the knowledge of these models are obtained from somewhere else. In this case, it's the open source data sets. So you have these open source data sets. Of course, you can naively just train some models on them, but it won't work because they look like nothing from our data, which brings us to the idea of domain adaptation. It means that we need to augment these open source data sets to make them look somewhat similar to what's in our data set. Then we can start training models on them. Speaking of domain adaptation, the idea can also be applied to, say, when we want to train the model that used to work on eons to work on comma 2s. We can just start by making the eon pictures kind of pinkish to mimic the IR lighting in the comma 2. And it's also the same trick when we want to transfer the comma 2 model's knowledge into the comma 3. Into the comma 3 capable model. That's how we ship the really good comma 2 that's how we ship that's how we make the common free DM model good at launch without actually using a lot of common free data. So after all that labeling and training, now we move on to testing, which is the most integral part for us to move forward and avoid regressions. So to test, you need a metric. What is a good metric for good DM experience? Is it model accuracy? Does a high model accuracy equal to a good experience? Well, not necessarily. Well, that's not true for DM at all, actually. Usually, like 99% would be fine, but now you're assuming the 1% bad experience is evenly distributed among all users. Then, in this case, all users are enjoying 99% of the experience. But in DM, usually, 99% means 1% of the users are constantly suffering and having constant false positive or something like that, where DM doesn't work for them at all. So how do we catch them? So to catch any of such bad experiences, we crunch numbers on every device in the training set and validation set. For example, here we try to see how often each device will get alerts with some candidate model we want to ship. Each dot here represents a bit device. We can see some device get a lot of DM alerts consistently, and it's important that we understand all these positives. For example, if this happens on me, where the model constantly thinks I'm distracted while I'm not, we need to find out why. It could be because the model doesn't work well enough when wearing glasses, or is it because the policy is too strict because I squint too much into the sun or something like that? These are the questions that inspire us to write more detailed tests and fix the problems they exposed. On the right is another example of testing by worst cases. According to this distribution curve, some devices are constantly failing to detect faces. Why? Is it due to the model not working in certain lighting conditions? Or maybe it's just the lens is covered? We need to figure them out. So by visualizing all these worst cases, we can easily identify what some of the problems are and what can be fixed, either by software or hardware. Say, for example, in the red ones, they're clearly covered and they're hopeless. And then in the black images, it's probably because the IREDs are broken, and that's a hardware issue. So the takeaway is we can learn and improve things a lot by just looking at the worst cases. All right, on top of everything I've talked about so far, I would like to also add some comments about thinking DM as a machine learning problem in general. So we currently have data uploads from about 1,600 users. And below is the amount of people from who we don't get DM data from, which is 75% of all users, which means for us as a company, we are stuck with this small subset of data to build a system which is expected to work on a much larger user base than the training set size. Well, now all this looks like a disaster for overfitting, especially when we have shown that even 99% isn't good enough. In other words, the model is only guaranteed to perform well on the people who's in the training set. What's the solution then? Well, how about more people consider uploading their driver camera, maybe? Well, it's just an informed recommendation. Absolutely nothing more than that. All right, seriously though, turn it on to help yourself and help others. Now, let's move on to what's next. Apparently, the next big thing would be end-to-end DM, where we will move the boundary between perception and reasoning like we did in the driving model. The DM model will have only one output called eyes on row, unlike in the classical model where we output many parameters of the driver and did a lot of complex math on that and figure out whether it's distracted or something. And actually, we are now actively working on getting automatic rank through working on this end-to-end pipeline. Pretty exciting stuff. Also, to give the model more context, we are also considering making it temporal. or training back models on the Common Freeze 180 model to make it see more. So yeah, there are so many potential big improvements we can make to stay ahead of the DM game. Very exciting stuff. That's it from me today. Thanks for listening.
All right. How many of you are going to turn your driver monitoring toggle on? Right. All right, here we go. Jason?
Thanks. This is a lot of good info. Can you talk a little bit more? You said there were times when the DM model would kind of relax versus tighten up its requirements for paying attention. Is that more than just stopped versus not stopped right now?
So in the driving model, it outputs the probability of you like being engaged, and also the probability of you like disengage in so many seconds in the future. So we use all that information to like adaptively set the threshold based on the scene complexity that the model thinks like when it will fail, so that such that the DM model can be more relaxed when, say, it's driving on a straight highway compared to it's like stuck in traffic.
Okay, so every once in a while I see someone question, I tried closing my eyes and the DM model didn't do anything, or I tried doing this or that, or I looked away and it didn't detect anything. And a good explanation for that might be that it's relaxed a little bit because this is a simple scene with a low probability, according to the model, of the driver having to grab control.
Yeah.
Would that be fair? Okay.
Thank you.
It doesn't mean you can ever not pay attention, though.
That's right.
My question is more about future possibilities with the comma 3 and the 180-degree field of view. Obviously, there was some questions about a sentry mode and comma security and all these things. Do you think implementing some of those features into the official release of OpenPilot may encourage, with like a prerequisite of needing to upload your driver monitoring to record these events, could help encourage more people to use that feature and upload because they're getting more benefit from it, when right now they may just feel that it's only a benefit for comma at a cost of their privacy, where you could give them security at a cost of their privacy and they may consider it.
Yeah, so we are considering that. So actually, we are actually also considering using the Comma Freeze 180 like driver camera to extract some of the like information for driving, which is like the offering like we can do, like you mentioned. So what we can do is like if we can somehow make the users upload with that, and if they don't like it, they can like choose to blur out their faces, then that would be great.
Quick question for you. Are you always limited to using the DSP? Will the OpenPilot team ever give you more compute if you ask for it? And is there any difference between the C2's Qualcomm, I think it's an 820 or 825's DSP versus the C3's 845?
The C-Freeze is way better. But we are only using, say, 10%, maybe 12% potential on the C2, so there's a lot of room for growth.
Got anything in the crowd? All right, we got someone upstairs?
Not really a question, but a comment. Thank you for looking at the scratching your head. Just distraction warning, because I get that all the time.
No worries. Gotcha.
All right.
You mentioned transfer learning from training on some general object detection data set with some kind of augmentation. Are you doing like self-supervised pre-training, or could you explain that a bit more?
Well, you can do augmentations like color, like mimicking, or you can do like something like Fourier domain adaptation to mimic like the sharpness on like a finer level of the image to make them look more like the ones on our data set. Does that answer your question?
And you aren't directly training the efficient net. You're training a teacher policy
Yeah, we first generate the ground truth using the ground truths using the teacher networks on our data, and then we use our data and those labels to train the efficient net to make the model perform.
Have you ever considered using a monochrome IR camera? It looks like there is some color data of maybe limited use on what we saw in the demos.
We are not having problems with using like RGB IR cameras, so I don't think that's a limiting factor for us so far.
So given that this is an opt-in, are you currently tracking the users who show a high, what's it called? The
Distraction.
The distraction level on a consistent basis, and would you ever seek action to ban those users? Is that a consequence?
No.
Oh.
You want to put up with the beeping. I mean, you know, if you choose to not pay attention, you're an idiot. But don't mess with your DM. If you mess with your DM, I'll ban you.
From the man himself.
You heard it.
That's right.
Hey, so kind of a broad question. So it's totally understandable why you need to like work on DM and have some way to like be able to alert the driver and even help them and perhaps even hold them accountable. Maybe that's taking it too far, but at the same time you also say stuff like, and I realize it's maybe half joking, but like we're L2, we take no accountability. So I guess what do you see as the purpose of DM to the extent that what I'm saying of the company not taking any, maybe I meant to say liability instead of accountability. Not taking liability, like, what's the purpose in light of that?
It's not like a liability level. It's more like you want you want to remind the driver that the limitation of the system and what their expectation of the system should be. And by using DM, we are ensuring that concept is always present. Does that answer the question?
I think so.
Thank you.
Since in the future you guys are going to be using the front-facing camera for the driving portion of the Open Pilot, are you going to be doing 2 passes, basically process a frame of video for driver monitoring and then reprocess the frame again for the driving? Or is it going to be all amended into just one process?
We'll see. So now we have the super combo. Maybe there's a super combo in the future using all 3 cameras.
Hello. Have you considered incentivizing users to upload their video as an investment in improving the overall effectiveness for everybody?
Yes. I mean, if you upload, it works better on you. So, I mean, that's the direct incentive.
Comma points obviously are very valuable. The more you have, the more important you are. So. All right, that looks like it.